All right, this is Honors Algebra 2 Pre-Calc. We're doing 4.1 in Algebra 2, and this is our third video in the sequence where we're just going to do a bunch of practice with operations with matrices. So here I've given you 4 matrices, and you're going to do a bunch of different operations with them. So this might be one of those rare instances where it's worth putting in your calculator if you want. So only because it's the same 4 matrices over and over and over again, and you're going to keep doing stuff with them. Now, that said, I'm going to do these by hand, but I do just want to show you what would happen if you put these in. So I'm going to go to second matrix. I'm going to go over to edit. In the first one, my A is a 2 by 2, and my numbers are 5, 3, 0, and 1. Before you quit out, you should check that it's right. So 5, 3, 0, 1, and that is correct. So then I quit out. Then I go back to second matrix, and you can see that this is not a short process, right? I go to 2, 2 is B rather, which was 2. B is also 2 by 2, and then it's going to be 3, 9, 2, and negative 1. And again, before I quit out of this, I want to make sure that's right. 3, 9, 2, negative 1, and then I quit out. Then I go back to matrix, and you can see how this takes a while, right? So I go to edit. I'm going to go ahead and pick C, right? C is supposed to be a 2-row, 3-column matrix, so 2 by 3. And I'm going to get 4, 2, negative 1, 0, 1, and 3. Now, I could have done this ahead of time, intentionally didn't because I want to show you the process of how you would enter these. All right, so when last I cut off, I just cut off and I was entering matrix C in there, and in the in what time we had, since the video cut off, I did enter D. So if we go over to edit, you'll see that my matrix D is also done. Okay, so there's my matrix D. So all 4 of the matrices are now in my calculator. So what I can do is I can go ahead and type in 2, right? Matrix A I get to, so I type in 2. To get to matrix A, I go to second in, sorry, not second x squared, second inverse. Go to second inverse, we pick A from the names menu, right? Plus 3, second x inverse, and I pick B, and then I hit enter, and there's my answer, right? So my answer is 19, 33, 6, negative 1, and that's fine, right? That's great. But you should still be able to do it without your calculator, right? So that's the idea. So if we were doing this without a calculator, right? If I were doing this without a calculator, there's a couple different options. One option is to go ahead and write what 2a is first, right? 2a would be 10, 6, 0, 2, right? Plus I could write what 3b is, which would be 9, 27, 6, and negative 3. And then I can add them together pretty easily, and when I do that, I'll get my 19, 33, 6, and negative 1, which is exactly what we got when we put it in the calculator. No big deal, right? The other option is you can try and hold it all in your head. If you want to do 2 times 5 plus 3 times 3, that's 10 plus 9, which is totally a 19, and that's fine, right? So one thing to notice here is that before you do a ton of work on these, some of these are going to be dimension mismatches. Specifically, A and B are both 2 by 2 matrices, and C and D are both 2 by 3 matrices, which means that B and C is not possible. If you're adding B plus C, it's not possible because of a dimension mismatch. So you could do the work to start to find what 2b is and to start to find what 2c is, but there's not a whole lot of point because it's a dimension mismatch. By the same argument, 3a minus 10d, well, a was 2 by 2 and d was a 2 by 3. So this is also going to be not possible by a dimension mismatch. So in both cases, these are both not possible because the dimensions don't match. Now 6c minus d would be possible. So when you do that one, you might want to go ahead and find, I'm going to just give myself a little bit of space here. So 6c, which would be 24, 12, negative 6, 0, 6, 18, right? And then I'm subtracting whatever d is. So 4, sorry, that's a positive 4. My brain is tragic. Negative 6, 5, 4, negative 1. Okay, so it's this number minus the corresponding number, right? So my answer is going to end up to being 24 minus 4, which is a 20, right? 12 minus a negative 6, which would be an 18. Negative 6 minus a 5, which is a negative 11. 0 minus a 2, so that's a negative 2. 6 minus a 4, it's a regular 2. 18 minus a negative 1 would be a 19. Now I can confirm that by typing into my calculator the 6c, so 6 second inverse 3 minus second inverse 4, and I hit enter, and there's my numbers, right? So I get 20, 18, negative 11, negative 2, 2, 19. Great. Now, what would happen in your calculator if you tried to do either of the other two? Well, let's see what happens if we do 2 alpha, second inverse b, my bad, plus 5 second inverse, and then C, and I hit enter, and sure enough, it tells me dimension mismatch. There's an error, right? Now, you can pick which quit or you can pick go to, doesn't matter, but if you pick go to, it's just going to tell you, hey, they don't match. Like, it doesn't show you anything other than, hey, this matrix is an issue. This one's fine, but when you try to add this one, it doesn't work. So if you get an error, that's why. Cool. All right, let's go on to our P8. Cool. So same idea. It's your call if you want to put these in your calculator. I personally don't know that it's worth it. It depends on the situation. When we get to matrix multiplication, which is a much more lengthy process, and that'll be in 4.2, then you're probably going to want to put them in your calculator. But for addition, I don't really think it's worth it. What I would suggest you notice first is that A and D are the same dimensions, right? A and D are both 2 by 3, excuse me, and B and C are both 2 by 2, which means A and B will be not possible because of a dimension mismatch. Right? Not possible because of a dimension mismatch. So dimension mismatch, meaning they have to be the same dimensions to add or subtract them, and they're not. So A and B, not possible. By the same argument, C and D will also not be possible because C is a 2 by 2 and D is a 2 by 3, right? So not possible. Now B and C will work because they're both 2 by 2 matrices, and A and D will work. So let's go ahead and do B and C. So negative 2b, again, I think the easiest thing to do is just go ahead and do negative 2b first as a matrix. That'll be a negative 6, a 4, a positive 8, and a negative 12, right? Plus, and then 10c is going to be 70, 0, 10, and 30. So I think we get 64, 4, 18, 18. And we can double check that if we want to put them in the calculator, but I'm going to say that it's probably not the best use of your time. Negative a minus 2b, so or 2d rather, so I'm going to do negative a first. That's a negative 5, a positive 3, a negative 1, a positive 2, a positive 1, and a negative 4, minus, and then 2d is going to be an 8, negative 12, 10, 4, 8, negative 2. So notice that I'm subtracting in the middle. So negative 5 minus the 8 is a negative 13. 3 minus a negative 12 would be a 15. Negative 1 minus a 10 would be a negative 11. 2 minus a 4 is a negative 2. 1 minus an 8 is a negative 7. Negative 4 minus a negative 2 would be negative 4 plus a 2, which is a negative 2. And there's my answer. Cool. And I think that's it for our video.